Hey everybody at home, hope you guys are doing well. Just want to give you a video lesson on what we did today in class. So if you're able to print these notes off, please do so. If you're not able to print them off, then just have some graph paper or the best you can nearby so that you can do these examples and keep them in your notes, okay? So yesterday we did an investigation of dilations, and what we discovered was that dilations are the fourth transformation that we're going to learn in this unit, and it's basically a resizing of a shape on the coordinate plane. So dilations can make your shape get smaller or bigger. So let's kind of fill in some definitions here, some words. Okay, so dilation, the enlargement, I'm going to write this here, enlargement, I'm going to make this a little bigger, or reduction of a figure. And the scale factor indicates how much the figure will enlarge or reduce. The variable that we usually use for scale factor is the letter K, lowercase k. So if your K is greater than 1, the dilation is going to be an enlargement. It's going to get bigger. So anything larger than 1 will give you a bigger object, so that's an enlargement. But if your scale factor, if your K is less than 1, the dilation will result in a reduction. It's going to get smaller. And that's what we learned yesterday in our investigation of triangles. So when you're multiplying by a number greater than 1, it's going to get bigger. When you multiply by a number less than 1, it's going to get smaller. And if you multiply by 1, it stays the exact same. Dilations result in similar figures. These are not congruent. Similar means same shape, but not necessarily the same size. So because these shapes are getting bigger and smaller, they can't be congruent anymore because their size changes. But they're going to stay the same shape, they're just going to get bigger and smaller. Okay, we're going to do a few examples here. Let's go ahead and start with example 1. It says triangle ABC with vertices listed there. Our K is 2. So that's our scale factor. That means we're going to multiply each ordered pair coordinate by 2. So that tells you right away, since this number is greater than 1, it's going to start out as the original, but the transformed figure, the dilation, will end up bigger. Okay, so the first thing we're going to do is go ahead and plot our original triangle. So let's do A, negative 3, 4. And don't forget to label, very important. B is 2, 1. And C is negative 1, negative 5. 2, 3, 4, 5. Connect our points. And we get triangle ABC. Now, what we're going to do is we're going to take each of these ordered pairs, highlighted in yellow, and we're going to multiply every single number by 2. Okay, I'm going to change colors to show my new dilation. Go red. So negative 3 times 2 is negative 6, and 4 times 2 is 8. Okay, B prime. 2 times 2 is 4, 1 times 2 is 2. C prime. Negative 1 times 2 is negative 2, and negative 5 times 2 is negative 10. Okay, now we're going to plot our prime coordinates to see how this changed. So A prime is negative 6, 8. That's up here. B prime is 4, 2, so right 4 up 2. And C prime is negative 2, negative 10, left 2, down 10. All the way down there, and that's C prime. So if I connect those points, you can see it gets much bigger. And what actually happens is each of those side lengths double, okay, to get our new figure. All right, so that's a dilation with a scale factor of 2. We multiplied every single ordered pair by 2, and our dilation was bigger than what we started with. All right, very good. Let's move on to, let's go down to number 3. Yeah, number 3 is good. Okay, number 3 says square EFGH and has the 4 vertices. And it looks like this time our scale factor is 1/2. So that number is less than 1. So you should have an idea of is it going to get bigger or smaller. Okay, so the first thing we're going to do is go ahead and plot the 4 corners of our square. So we're going to go E is right 8, down 8. 4, 5, 6, 7, 8. Hopefully I get these right. It gets a little blurry here. I'm not sure where that's going, so I'll just put my E there. F is right 16, down 6. 13, 14, 15, 16. 1, 2, 3, 4, 5, 6. So that should be there. Oops, there. G is right 18, down 14. 18. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my goodness, a lot of counting on this one. Okay, that's G. And then H is right 10, down 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 16. So that should be here. Okay. Connect those vertices. And we have our square. All right. Okay, now what we're going to do is we're going to take each of these ordered pairs and we are going to multiply them by 1/2. And remember, multiplying by 1/2 is the same thing as dividing by 2. You're just taking half of each number. So if we start with E, half of 8 is 4, half of -8 is -4. Half of 16 is 8, and half of -6 is -3. Half of 18 is 9, and half of -14 is -7. Half of 10 is 5, and half of -16 is -8. Okay. All right. So now we're going to plot our 4 new ordered pairs. And let's start with E prime, right 4, down 4. Don't forget that apostrophe. F prime, right 8, down 3. G prime, right 9, down 7. And finally H prime, right 5, down 8. Connect our corners and we get another square. This time it's much smaller. It's actually, each side length is half of what it was, okay? So when we took half of each ordered pair, it reduced it, and each side length is now half of what it originally was, okay? All right, let's go ahead and let's go to the back. I'm not going to do a ton of examples. I do want to call your attention to example 6. The scale factor on this one is, oops, that's an erase, 3/2. Now normally I would say when you're multiplying by a fraction, you're going to get a number that's smaller. But be careful because this is an improper fraction. And remember, an improper fraction is the numerator is bigger on top than it is on bottom, and that can be a mixed number. So 3/2 is actually 1/2. And is 1/2 greater than 1 or less than 1? Well, it's greater than 1. So this is actually going to be an enlargement. So don't let that fool you. Make sure you understand that you're multiplying by 1/2 or 3/2 or 1.5 if you like the decimal. Okay, you can use your calculator to do that. All right, we're not going to do that one though. Just want to call your attention to that improper fraction. All right, I want to do one more example. Let's see. Let's go to number 8. I want to do number 8. Do I want to do number 8? I don't know. Let's see. Basically, with these ones where they don't give you the ordered pairs, you just have to write out your ordered pairs first. So if you did number 8, what I would recommend doing, and I'm not going to do it here with you, but just write the original ordered pairs up here so that you can dilate them yourself. For example, Q would be what? -1, 2, 3, 4, 5, 6, 7, -8. And down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10. So I would just want to do each of my ordered pairs, write them here, then multiply each number by 1/2 to get my new ordered pairs. Okay, so it's not like you have to graph the first triangle. They already did that for you, but you do need the ordered pairs that go with it. Okay, so now let's just move on. Let's go to a number 11. It says identify the scale factor used to graph the image below. Okay, so in order to do that, what we're going to do is we're going to zero in on one point at a time. And it doesn't matter which one, but make sure they are coordinating with each other. So I'm going to highlight this here. I'm going to do P's. So here's P here and P prime. All right, let's start with the original P. And we're going to write down the ordered pair. So the ordered pair for P is over 2, up 1. So that would be 2, 1. Now I want to write the P prime, the second one. P prime is over 1, 2, 3, 4, 5, 6, 7, 8. And up 1, 2, 3, 4. Okay. So basically what you're doing in order to get that scale factor is you're trying to figure out what are you multiplying by to get from P to P prime. And this one isn't too challenging because I know I would have to multiply by 4 to get that, because 2 times 4 is 8 and 1 times 4 is 4. So my scale factor is 4, which makes sense because I'm starting out with this smaller object here, and if I multiply it by 4, it's going to get much bigger, just like that one right there. Okay, let's try one more like that, number 12. Let's go ahead and zero in on a specific variable. How about we start with H, and we go to H prime. So H, the ordered pair, is 9, -3. And H prime, the second one, always go in order, is 6, -2. Okay. Now, this one is a little more challenging because there's nothing, 9 times what is 6? I don't know off the top of my head. So I'm going to have to go backwards. So instead of multiplying forward, if you do the inverse and divide backwards, you'll get your scale factor. So if I take 6 and divide it by 9, I see that's a fraction and can be reduced to 2/3. If I take -2 and divide it by -3, I still get 2/3. So my scale factor is 2/3. Okay, so all I did, I changed that color up, is I divided backwards. Divide backwards, and that'll get my scale factor. Okay, so that should do it for dilations. Feel free to rewatch the extra help video from Tuesday that gives you information on dilations too. That should get you everything you need to know. So make sure you get down these examples in your notes, and the homework assignment is on Google Classroom. Okay, if you guys have any questions, just email me, and I'll help you however I can. Okay, thanks. Have a great day. Bye.